All right, let's jump right in. If you're doing any kind of research in second language learning, you are absolutely going to run into correlation. It's one of the most fundamental tools we have. So for your next MA lesson, let's make sure you are completely ready to not just get it, but to really think critically about what it's telling you.
You know, it all really starts with a super simple human idea. The statistician Andy Field tells this great story about learning to play guitar. And what his dad said to him, well, it wasn't just good fatherly advice, he was actually describing a correlation. He was saying, hey, there's a relationship between two things, how much you practice and how good you get. That's it. That's the heart of the whole concept.
Okay, so let's take that story and make it a bit more formal. How do we, as researchers, take an idea like more practice means you get better and actually measure it? How do we literally see that relationship in our data?
So here's the more, official definition. Correlation is basically a number that tells us how two variables are related. The key phrase here is that they co-vary. They change together. When one zigs, the other one zags in a way you can kind of predict. And honestly, the best way to get a feel for this is just to look at it. This is what we call a positive correlation. See how the dots generally trend upwards? As the thing on the bottom gets bigger, the thing on the side tends to get bigger too. That's the guitar story in a picture. More practice, better performance. In L2 research, you might see this with something like speaking and listening ability. Learners who are good at one tend to be good at the other.
And then, of course, you've got the opposite, a negative correlation. In this case, as one variable goes up, the other one tends to go down. The data points slope downwards. A really classic and powerful example from our field is the link between a learner's age when they arrive in a country and their grammar test scores later on. A lot of studies find that as age of arrival goes up, those test scores tend to go down.
And then, sometimes, you get, well, a whole lot of nothing. No relationship at all. The points are just a cloud, scattered all over the place. There's no line you can draw through that, no pattern. It just means the two variables are totally independent. Knowing about one tells you zero about the other.
Okay, so seeing the pattern on a graph is step one. But, science isn't happy until it can put a number on things. So how do we take that entire scatter plot, that whole relationship, and boil it all down to just one single powerful number? Well, the first step on that journey is a concept called covariance. It's basically a raw number that tells you if variables are moving together or in opposite directions. But, and this is a big but, it has a huge problem. It isn't standardized. Its value completely depends on the units you're measuring in, which means you can't compare the covariance from one study to another. It's just not a universal language. And that's where this brilliant solution comes in, Pearson's correlation coefficient, or what we all just call R. It's kind of genius, really. It takes that messy covariance number and standardizes it, putting it onto this perfectly clean, universal scale that always goes from -1 to +1. Suddenly, we can compare any two relationships from any two studies, apples to apples.
So what does one of these R values actually look like? Well, here's a real one from a study about exam anxiety. The correlation they found between how anxious students were and how well they did on the exam was R equals -0.44. Right away, just from that single number, we know two things. The relationship is negative, and it has a certain amount of strength. Okay, so you have the number. Let's imagine you just ran your analysis for your MA project, and the computer spits out this R value. Now what? What do you actually do with it? How do you turn that little number into a real, meaningful insight? It's actually a pretty straightforward three-step process. First, just look at the sign. Is it plus or minus? That tells you the direction. Is it an upward or downward slope? Second, look at the number itself. Just ignore the sign for a second. The closer that number is to 1, the stronger the relationship is. So an R of 0.8 is way stronger than 0.2. But it's this third step. That's where the really cool insight is hiding.
Now this is where things get really powerful. If you take your R value and you square it, you get something called R squared. For that anxiety study, R was -0.44. Square that and you get about 0.194. So what does that mean? It means that 19.4% of the differences we see in students' exam scores can be explained by their level of anxiety. It tells you how much of the story one variable tells about the other. But, and this is huge, look at the chart. That also means over 80% is explained by everything else.
And this leads us to what is, without a doubt, the single most important lesson about correlation. This is the one thing that, if you remember it, will immediately elevate your thinking. This is the golden rule you can never, ever forget.
Here it is. Write it down. Correlation is not causation. Just because two things change together, even if it's a super strong relationship, it does not mean that one thing causes the other. To say that anxiety causes bad exam scores is a huge leap, and it's a leap that the correlation data itself simply does not let us make.
So why is that? Well, there are two big reasons. First, what we call the third variable problem. Maybe there's some other thing we didn't measure, like how much sleep the students got. Maybe lack of sleep causes both high anxiety and poor exam performance. The second reason is the directionality problem. One study found a nice correlation between good pronunciation and a learner's satisfaction. But does good pronunciation make you feel satisfied? Or does feeling satisfied and confident actually make you a better speaker? The R value has no idea. It can't tell you which way the arrow points.
All right, now that you've got a solid grip on the fundamentals, let's take a quick peek at a couple of other advanced terms you're definitely going to bump into as you read research articles for your classes.
You often see two main types of correlation. There's Pearson's R, which is the one we've been talking about. It's the go-to for what we call parametric data, your nice, clean, normally distributed numbers. But what if your data is just ranked, like first, second, third? Or if it's not so nicely behaved? Well, then researchers use an alternative, like Spearman's row. The key takeaway for you is just to know they measure the same basic idea, just for different kinds of data.
And hey, remember that whole third variable problem we just talked about? Well, guess what? There's a tool for that. It's called a partial correlation. It's a clever statistical trick that lets you look at the relationship between two things, A and B, while mathematically holding a third variable, C, constant. It's a way to try and get a cleaner, more honest look at the relationship you actually care about.
So, that was a pretty fast tour. We've covered a lot of ground. Let's boil it all down. What are the absolute essential things you need to have locked in before you walk into your next class or start your next project?
Here it is, your MA Toolkit, 4 simple rules. Number 1, always look at your data first. Make a scatter plot. Don't just blindly trust the numbers. Number 2, interpret both parts of R, the direction from the sign and the strength from the value. Number 3, use R squared to talk about the real-world importance of what you found. And number 4, the golden rule, say it with me, never ever assume causation from correlation.
So I'll leave you with this final thought. The next time you're reading a journal article and you see a correlation reported, what's the first question you're going to ask yourself? Will it be about the strength or the direction? Or maybe, just maybe, you'll find yourself wondering, what's the third variable that the authors might have missed here? That is the kind of critical thinking that's going to make all the difference for you.